Hello everyone! In this video I will give you an in-depth breakdown of how this image of a robot child running in its flip-flops, dreaming of being a pilot, was created. If there is something more you would like to know about the process, feel free to ask in the comments. I will be more than happy to provide you with more insight. With that said, let's get straight into the breakdown. Everything started with this great illustration by our concept artist Zlatan Rangelov. The illustration looks very dynamic with interesting shapes and lots of details. That's precisely what I wanted to transfer to the 3D image. I began by modeling the robot itself. When creating a character, the first thing to think about is the basic shapes. That's why I started with simple shapes that can be easily modified. The idea is to capture the overall proportions and gradually improve it. For the creation of the models, I used 3ds Max and ZBrush. In the initial stages, the model looked funny, but I didn't worry too much about it, as I knew I would improve it later. To create the jacket and the helmet, I used ZBrush. Again, I didn't focus too much on the details, but just on the overall shapes. When I was satisfied with the form, I marked where I wanted the stitches to be, and added some folds. Then I imported the model back into 3ds Max to create a correct topology for both the jacket and the helmet. Creating good topology is essential for texturing and for posing the character. When I was ready with the geometry, the final detail I added was the lines indicating where I wanted the stitches to be. I continued working on the robot itself, refining the shapes and adding details. I followed the concept image closely, modeled the goggles and positioned them on the head, and that was the final result. The next step was preparing the model for the texturing phase. Before texturing, we have to unwrap the model to avoid stretching when we apply the texture maps. I unwrapped every single piece of the character. To create the textures, I used Substance Painter. I had to prepare the model before importing it. You can see how I grouped the pieces in different colors. When I import the model, the pieces will be separated into different sets. I separated the pieces that intersect or are too close to each other. The reason for doing so is that it will make it easier for Substance Painter to bake the model, and also it will make the texturing process more organized. Now I can select the model and export it using the FBX format. When the model is imported into Substance Painter, you can see that it has different texture sets. The baking phase is very important as it generates maps like curvature, world map and AO maps, which are useful when creating materials like worn out metal. Now it's time for the most fun part, the texturing. First, I created a base metal layer and applied it to all metal pieces. On top of the base layer, I added some worn out paint. Substance Painter provides masks that will allow you to control the wear effect. I went through all texture sets and applied the same layers. To add more variation, I made some pieces in bronze. For the hoses on the back of the legs, I created a rubber material. That is how I also approached the texturing of the leather jacket and the helmet. Now it was time to export the textures. In V-Ray there are two workflows we could use: the specular glossiness workflow and the metallic roughness. I will follow the metallic roughness workflow, which is a straightforward method for using PBR textures. If you want more insight into the two workflows, you could check our blog post Understanding Metalness, With that said, I will go to the Export Textures menu and choose the V-Ray Metallic Roughness output template. When we click on Export, Substance Painter will export the textures we need, but I won't apply them just yet. First, I wanted to pose the model, find a good camera angle, and set up the lights. To pose the character, I wanted to create a very simple rig using hierarchical links. Hierarchy links are very useful if you want to rig simple mechanical joints like on this robot. First, I started with the flip-flops and linked them to the feet, then the feet to the legs. This method was used for everything else. It is very important to ensure the pivot is in the correct position. This way, moving the character is much easier and can save a lot of time. Now it was time to set up the camera. I used a V-Ray physical camera. From the render setup, the proportions and the resolution can be adjusted. After that, I started posing the character. For now, I had to hide the jacket to pose the arms. When I'm ready with the character's pose, I will pose the jacket separately in ZBrush. When I was happy with the pose, I added the model of the plane, which was modeled using only 3ds Max, and added the ground. To enhance the image, it's important to find an interesting camera view. I placed the camera slightly below the character to make it more dynamic. From the camera options, the focal length can be changed to achieve a more dramatic effect. Now it was time to pose the jacket. I imported the posed character into ZBrush and started modifying the jacket. I did it by masking the parts I needed and rotating them carefully. As I mentioned earlier, with good topology, the posing process is much easier. I returned to 3ds Max and added the model of the oxygen mask. For an effective render, it's crucial to have a good lighting. For this image, I used V-Ray Sun. When lighting an image, I start with gray materials only. This way we can see clearly how the light interacts with the objects and find the best look. I liked the position of the sun, but I wanted to block some of the light, so I created a simple box to serve as a light blocker. This light blocker casts shadows to certain areas and makes the shapes of the robot pop out. Now, if you want to add some clouds to the skies, you have that option with V-Ray Sun. You can turn on the clouds option and adjust various settings to your liking. Overall, I was happy with the lighting in the scene, but I wanted to have some control over them in post-production. That is why I decided to add light mix. From the render setup menu, you can add a light mix render element. When you do that and re-render, you will have the option to control the colors of the lights. I wanted to add some warmth to the sunlight and make the shadows slightly bluish in color. When I was ready with the lights, I moved on to the shading phase. I started with the default gray material. As I mentioned earlier, I used the metalness workflow. The first thing to do is switch the BRDF to roughness. Set the reflection color to white. because in reality all materials have some reflection, whether it's metal, wood or plastic. You can control the shininess of the material using the roughness value. If you have a metal material, turn the metalness value to 1. Currently the roughness of the material is set to 1, which is the maximum level. Setting a lower value will make the material shinier. To further control the shader, you can use textures. I imported all the textures I had created previously. Now, when using data maps such as roughness, metalness, normal and so on, you should tell V-Ray to read them in linear color space. You can do this by setting the color space transform function to none and switching the RGB primaries to raw. This is done because when you import a texture, the gamma is automatically changed, which can make the texture appear incorrect. When the maps are ready, connect them to the corresponding slots. Here is a preview of the metalness map. It is a black and white image controlling the metalness of the shader. In the white areas, the material will exhibit metallic behavior, while in the black areas, it will be non-metallic or dielectric. Finally, I connected the roughness map to control the shininess. This is how all the materials were made. For some of the materials I used shaders from the Cosmos library, which has a huge collection of shaders. With the character ready, I continued working on the environment. First I wanted to make the ground more detailed. To add some detail to a certain surface, you can use V-Ray displacement. It uses texture maps to make deformations to the mesh. Here I prepared a texture of desert sand, which I plugged into the V-Ray displacement. To make it more lively, I needed to scatter some desert grass and rocks. To do this, I used Chaos Scatter, a system that allows you to populate the scene with selected objects. The Chaos Cosmos library had the perfect models for my case. To use it, create a scatter object. Then pick the objects you want to scatter. After that, from the Distribute on Target objects, add the surface you want to scatter on. You can control parameters like density, scale, and rotation of the objects. If you want to exclude an area from being affected by the scatter, you can create a spline and add it in the Areas menu. As you can see, now the spline marks where the objects will be scattered. I also created a scatter object for the rocks. Reduce the density and scale them down from the Scale menu. Some of the rocks appeared to float above the ground, so I adjusted their position using the Translation menu. Chaos Scatter can be used in various creative ways, not only for scattering grass and rocks. Here is how I used it to create the stitches on the jacket. What I needed was a simple model of a single stitch that I would scatter. I selected it together with the jacket and isolated them to work faster. Next, I added an Edit Poly modifier on top of the Turbo Smooth. This will enable me to select the edges I needed. I generated a spline from these edges by clicking the Create Shape button. Now I can create a cow scatter object. For this case, I use the 1D scattering mode, which is used to scatter objects along splines. You can change the preview from wirebox to full mesh to see the results. I scaled the scattered objects to around 2.5% and reduced the space between each stitch to about 0.8. It looked fine, but the rotation was incorrect, so I adjusted it as well. The stitches, as you can see, were intersecting with the jacket. I wanted to move them up a little bit, and just like I did with the rocks, I did it from this parameter. That's how all the stitches were made. Now we are almost ready with the character. One last thing I wanted to add is some fur to the cloth pieces of the jacket. Let's take a look how I use the V-Ray fur tool to make the color of the jacket more detailed. I isolated it to focus on it. With it selected, I simply clicked on the fur icon on the toolbar. I had to adjust its properties a bit to make it work better. I cut some of the length and adjusted the radius of the fur strands. I tweaked the gravity and bent a bit. Also added some tapering so that the hairs got thinner at their tips. To make the fur look more natural, I introduced some clamping to it, making groups of individual hairs converge into a single cluster. That was done by using the map parameters of the fur. I had a simple RGB map prepared that was plugged into the direction slots of the fur. This way we can achieve some simple clumping effect. They seemed a bit too uniform and perfect, so I added just a little curve to break things up a bit. I also increased the number of hairs slightly. Now that I had successfully groomed it, let's see how the fur was shaded. When it comes to shading any sort of hair object with V-Ray, the go-to option is the V-Ray Hair Next material. I created one and applied it to the fur. By default, it's getting its color from the melanin parameter. This provides a great selection of natural colors. However, for this example, I changed things a bit. I upped the diffuse amount all the way to 1, changing the behavior of the shader. Using this approach works great for thick types of fabric that don't exhibit much translucency. To introduce some color variation, I plugged in a grunge texture. Also, the hair input texture can be used to add some additional effects to the shading. I used it to make the tips of the hairs brighter. I color corrected the texture and plugged it into the second slot, and used the bias parameter to control the effect. This is how we can quickly create a V-Ray fur, do some basic grooming and shade it properly. With that, I was ready with the robot and continued to work on the environment. The sky seemed too clear to me. When you have an outdoor render, adding fog will help you get a more realistic result. To add it, go to the Environment menu and in the Effects panel, add a V-Ray Environment Fog. By default, it may appear too dense. Increasing the fog distance will fix this. You can modify many things like the color or height of the fog, but I only changed the distance and enabled the Scatter GI option. This option makes the fog look more realistic, but it can increase render time. I liked the impact the fog had on the environment, but I didn't want it to affect the character. So I limited the fog using a gizmo box. From the atmospheric apparatus, you can create a box gizmo. Change its size and place it where you want the fog to be. As you can see, the character is outside the box. Now when you go to the fog menu, you can add the box or whatever object you have created and add it to gizmos. This way the fog will appear only inside that object. This way I added some haze to the environment, making the character stand out. To make the image more dynamic, I wanted to add some dust beneath the character's feet as he jumps. To create the dust effect, I used Phoenix AFD, a tool for creating effects like fire, smoke, explosions, and more. I created the simulation separately and imported it into my scene using the V-Ray volume grid feature. To add extra action to the scene, I needed motion blur. I wanted the character to stay in focus and blur everything else. To achieve this, I had to move the character together with the camera. So I selected our hero and the camera and isolated them from everything else. Then I created a dummy object and using hierarchy links, attached all objects to it. Now I could control the whole character together with the camera using this dummy box. Now I had to create a simple move animation. To create an animation, you have to click on Auto key. I wrote down the original position of the robot, moved it back slightly, and then moved the frame slider to the 10th frame. And then returned the robot back to its original position. You can see how a keyframe was created and we have the animation. Now I just had to enable the motion blur option in the camera settings. From the shutter speed, you can control the effect. A lower shutter speed means more motion blur. Now when I was happy with how everything looked, it was time to create the final render and add some color corrections. From the render setup, I changed the image sampler from progressive to bucket and left the default settings. In most cases, the default settings work perfectly fine. Color corrections can be done directly inside the frame buffer, so you don't have to use any external softwares. I lowered the exposure slightly, then added a filmic tone map. I used the high Dawson, which worked best for my image. And that is the final result. Thanks for sticking with me to the end, and I really hope you gathered something useful from this breakdown. Thanks a lot for watching.